Have you ever wanted to know more about the programming world, or how programs work? Or maybe you wanted to have an intuition about what is expected in a computer science class? Great, so you're in the right place. Let's begin with some motivation. Why would we even want to learn computer science? Our main goal is to let the computer do something for us, but computers don't understand our own language. So we have to communicate in the language the computer understands. So what kind of language the computer understands? In the most basic level, the computer is only able to execute commands that are written in machine language, which is composed of sequences of zeros and ones, where 0 represents that there is no voltage and 1 represents that there is voltage. You see the problem with that already? It is super hard to be able to write programs using such a language, not mentioning that the code will be different between different hardware types, so what you need to write on my computer is different than what you need to write on yours. I hope we agree there is a gap here between our desire to communicate with the computer with simple language to the machine language you just saw. Let's see what is the process to overcome it. The first step in the process is to define an algorithm. Algorithm is a sequence of instructions that solves the problems we want to solve, similar to a cooking recipe to make a pizza, for example. The algorithm can be described in pseudocode rather than a programming language, which means using plain language to describe the algorithm. Let's go over an example. Say the problem you want to solve is writing a program that says if user input is an odd number or not. There can be more than one solution here, but let's see a possible one. We start with printing an instruction to the user to enter a number. We then need to read the user input. Once we have the input, we can first check that the input is indeed an integer, and if not, we print an error message. Now that we know it is an integer, we check the remainder when dividing the number by 2 to determine if it is odd or even. And then we print a message with the result, and we're done. Two things to note here. One is the checking for the remainder after dividing by 2 is a straightforward action, which we'll see in an example later. And second is that pseudocode helps us to shape our solution, but in order to be able to run it on the computer, we need to write it using a high-level programming language, which will be the next step in our process. Let's see what are high-level programming languages. High-level programming languages simplify the programming process, as they are readable to humans. Unlike sequences of zeros and ones, they also have abstractions, such that writing one command in a high-level programming language usually equivalent to multiple commands in machine language. For example, in most programming languages we can write something similar to this. A print command where we ask to print the result of a simple mathematical expression. We can agree that it is fairly readable and short, but in machine language it is likely to span over multiple commands, such as store 2, sum with 5 and override 2 with the result, multiply by 7 and override with the result, copy the result to other place, and it may go on. I am sure we can agree that this is tedious comparing to the print command on the left. There are many programming languages out there. Here are a few examples for very popular ones at the time of making this video, and the syntax of the print command in each one. Some programming languages are used for similar purposes, and some are used for different purposes. The differences between the programming languages include syntax, level of abstraction, common practices, and more. But once you master one or two languages, it is easier to learn a new one, as there are usually many similarities. Let's go back to our example of a program that checks if a user input is an odd number. Before, we saw a pseudocode solution for this problem, and now we are going to code it. For this video, we'll use C language to exemplify the programming process. In this video, we won't explain in depth every single command, as this video is not about the C language. If you'd like me to make a video that covers this example with more focus on the C language syntax, please let me know in the comment section. Alright, with this in mind, let's see the code. We write the code in a file called ishod.c. Let's go over it briefly. The include stdio statement at the top has no reminder in the pseudocode. It is our way in C to be able to use standard input and output commands as we are doing below. Our entire logic is written within a block of code under a function called main. You see, we open a curly brackets here and close them at the bottom. This is called a block. The main function is the entry point of the program, meaning that when running the program, the computer will run the commands written right here first. The first statement inside the main is the request for the user to enter a number. It just prints the string here to the screen. It doesn't wait for the input. To get the input, we define an integer variable, which is a placeholder where we can store the number entered by the user. We then use a scanf command to wait until the user enters the number and store it in the variable. The scanf command also helps us to understand if the user input was a number or not, so we can print an error message if not. Then we have a valid integer number and we check the remainder when dividing it by 2, using a built-in operator, and print that it is not odd if there is no remainder, as it means the number is even. Finally, if both conditions above did not meet, we can be sure that the number is odd, and we print it. Again, this was just a quick overview, and if you are interested to learn about the syntax here in more depth in a different video, please let me know in the comment sections below. Now that we have a source code file, our next step is to compile it. Compiler is a program itself, that its input is the source code and its output is a file in a language that the computer understands. In our case, we give the compiler our isodd.c file, and it generates isodd.exe if you're on Windows, or just isodd if you're on Linux or Mac. The content of the output is not human readable, and we can run this file in order to run our program. If there is a syntax error in our source code, the compiler won't be able to generate the output and it will let us know about the error. For example, let's assume we mistakenly missed the AND letter in the printf command. When compiling this file, the compiler will print an error saying that the method printf is not declared. Then we should fix and run the compiler again. And now it works. It is important to note here that if our mistake in the code is semantic rather than syntactic, the compiler won't be able to alert us and will succeed. For example, changing the condition here by replacing the 0 with 1 would cause the program to print that even numbers are odd, and odd numbers are not odd, which is the opposite of what we wanted to achieve. Yet it is perfectly legal code and the compiler won't complain. Therefore, an important part of the programming lifecycle is to test the code that you write, by running it on example inputs and see it returns the correct results. Now we have a file ready to run, but let's have a look first at how a computer is structured. First we have input and output tools, like keyboard and mouse, which we use to provide input to the computer, and tools like monitor to observe output from the computer. Inside the computer we have an important component called RAM, which stands for Random Access Memory. This is where the commands and data of programs are being saved while they are running. While they are running is an important distinction here. When the program is not running, it usually doesn't have data in the RAM, and when the computer is turned off, most of the data on the RAM is not saved. RAM is usually very fast, much faster than hard disk for example. The RAM can be thought of as a very large stack of cells, where each cell has a unique address and can store a small amount of data. Another important component is the CPU, which stands for Central Processing Unit. The CPU is in charge of reading commands from the RAM, decode and execute them. Next we have storage components. We store our data, like files or the programs we use. And unlike the RAM, These components are intended to save data in a persistent way, so if the computer is turned off and then turned on again, our data will still be there. In computer terms, accessing the data is much faster on the RAM than on the storage components, so only data that is currently needed by the computer is loaded from the storage to the RAM. All of these components and more that we don't include here are connected together by the motherboard. Each component is plugged into it and can communicate with other components that are plugged. To summarize, we have our compiled file on the disk, and when we double-click on it, its content is loaded into the RAM. And the CPU is starting to read the commands from the RAM and execute them one after the other, controlling the flow of the program. I hope you now have a better understanding of how programs work. If you like this video, please make sure to hit the like button and subscribe to the channel.